Good morning and good afternoon. I don't know what time you will be listening to this video. And this is from Yebo Physics. Hopefully, I'm expecting somebody to join me both on Teams as well as on YouTube. Let me check if I see anybody on the YouTube. YouTube guys, I don't see you, but just please, I don't know if the system is alright, if my voice is audible, if you see what I'm talking, please let me know. Hi, let me go just say hi. If anybody join me, please, you can type your questions or chat with me. Basically, what I planned for this morning is on the tutorial 2, PHYV 101, tutorial 2, as well as FVV 101 from the physics workbook B. And then I will be concentrating on section 6.4 to 6.5. Very, very, very good questions inside there. I just had a glance to it. Guys, those of you on Teams or on the YouTube, please let me know if you could hear me, if the system is stable. Thank you. Is it from the Teams side? I believe so. Yeah. Okay, guys. Okay. Let me. I don't know if I can share. Me organize and represent. Oh, can share. Oh. The problem I have is James has set it up this thing, but I could not share. Okay, hold on. I will be speaking to my colleague if he can allow me to share my screen. Otherwise, my screen is I can't share. Just hold on for me, guys. I'm calling in between. You can't see me what I'm doing. James, Dr. James, you know what you did to me? And on the team link that you shared with us, where I joined the team, but I cannot share my screen. Yeah, please just take me through the sharing. It says only meeting organizer and the presenters can share. That means you have limited us. Okay, thank you, guys. And who am I speaking to? Who just spoke to me? One now, please. Those of you on the Teams, can you hear me properly though? Andreas, your name is in front of me. Thank you. Yeah, thank you. And are you from PHYV or are you from FVV? PHYV. Therefore, I'll take that one. The other ones, Lemelo, Gosana, you guys, how are you? Are you also from PHYV? Thank you. Okay, Gosana also hope so. But I will go with you first, and then I'll jump into the FVV later on. Therefore, and you guys, do you have maybe in the last week about the vector unit of measurement and the vector? Are you guys happy with that? And you okay with it? I'm just waiting for James also to give us that access. Therefore, what I'm asking is on the last week's tutorial, which is about units of measurement and the vector, tutorial 1, how many questions? There are 15 questions. If you have any question, if you have anything that you would like to discuss, you are welcome. We will also, as a group, will also update for you the solution soon. That means you will have a written solution. We're going to post it just below your lecture slides, no, not lecture slides, just below the tutorial questions. We'll upload the solutions also. I'm just waiting for James to share with me. Then we'll continue from that on. Let me check those people on the YouTubers. I don't see that much activity. Yes, there is one currently 2 viewing. I could see, guys. If you are there with the YouTube, can you hear what I'm discussing? I'm waiting. Technically, I want to share my screen with the Teams. Therefore, I'm waiting for access to be allowed. Then I will be with you. In this today's tutorial, mainly I will be concentrating on motion in 1 and 2 dimension for a PHYV class. Tutorial 2, question 5 to 8. That's what I will be concentrating on. Hoping that James is gonna release me soon, and once he release, I'll be with you guys. What I'll be working is it's difficult to work without you seeing what I'm doing. I want that access, the Teams access quickly. Hopefully James is gonna come soon. Oh yeah, now I can. Thank you, James. I'm gonna share which screen. I want this screen to be shared. Now, Teams guys, please confirm with me. Can you see the screen I'm watching? It says it's just basically Yebo Physics tutorial schedule. Semester 1 2023, handwritten PHYV 101 and FVB 101. Can you see those of on Teams? Thank you. Good. That means we are in. Then let's scribble slowly. That's where I am now. Those of you on the YouTube also, you must exactly see what we're discussing with the Teams guys. As I said, I'll be starting with, let me speak to James. James is coming back to me. James Bond, thank you. I've got the access now. Yeah. Thank you. Bye. This is question number 5 for PHYV 101 again. Tutorial number 2. It's basically about a projectile motion. Remember your projectile motion? It's a 2-dimensional motion now. An object, or for everything in the projectile motion, as you could see, an object will be fired at a certain angle. That angle, the initial angle with which the projectile is to be fired, it must have an initial velocity, obvious. Therefore, because it is a 2-dimensional motion, you must be able to decompose the x component of the velocity as well as the y component of the velocity. Just basically, this is a vector stuff that we dealt before. If there is a vector basically in that way, which is b initial in this case at an angle of theta initial with respect to the x-axis, you could decompose this vector into x and y. That's mainly what you are up to. The x component is always v initial cosine of the angle theta, and as well as the y component, which is up, v initial sine theta. You must be able to decompose this vector into x and y component. That's the initial stuff that you should be up to. Okay? With this information, 2-dimensional motion, therefore this projectile actually continues to move into 2-dimensional along x and along y. Remember also, along x, there is no acceleration because the range r would be basically v naught x times t plus half at squared. You see, this is a 1-dimensional motion. This is a range. But remember, because there is no acceleration along x, obviously this component is 0. The y component, again, we're going to use for the y component, I'm going to write it here. Y is equals to v naught y times t plus half gt squared. Remember, because the acceleration is going up, acceleration due to gravity is always down, this sign changes to minus. There is nothing new you could add in these 2 dimensions. Therefore, whether it is a 1-dimension or 2-dimension, we are going to use the equation of motion that you basically dealt with in a 1-dimensional motion. Therefore, let's go back to my question. The question says, it was a firefighter, it says a firefighter, a distance d, this distance d, this is given from where it is standing and from a building, directed a stream of water from a fire hose at an angle of theta I. That is not U, this is a type error. Let's call it theta I. Above the horizontal, as shown in this figure, it says, if the initial speed of the stream is V initial, as it is given, what height h does the water strikes? I don't know why my YouTube is jumping and up and down. I don't know why it is not sharing. Maybe we are a little bit behind. YouTubers, the screen you see is still behind, but it's gonna come to you. This is a screen I'm sharing right now. Okay, therefore our objective is, what is this height h? The question we wanted to know is, what is h? D is known. The only thing you know is D is known. The initial angle with which the projectile is fired is known. V initial is known. Then you have to calculate. I don't know why this thing jumps up and down. YouTubers, you are not seeing. Now it is there. This is exactly the screen. If you are on a YouTube, guys, you could see. We can see. Thank you, Gobu and Kosana. You said we can see. Thank you. Let's go for it then. How do you solve? The answer is basically given. The final height that this water will strike on the building is going to be d tan of theta I minus g's acceleration due to gravity, d squared, divided by twice of the initial velocity with which it was released, cosine square of the initial angle theta. But this looks like derivative or derivation in terms of physics, but don't be frustrated. It's a very, very, very simple, straightforward. The only thing you should remember is this equation, the one I put for you there, as well as this equation. You see, to solve for y, what we are interested is about the y, which is v naught y sine times t minus, now because it's acceleration due to gravity, half gt squared. You know the initial velocity along y component, which is vi sine theta. The only thing you don't know here is the time. You don't know what time is how long this thing has been in flight. What should you do if that is the case? Remember, you have got another information. I'm hoping that those of you on the teams also listening to our conversation. The only information you had additional to v naught y and the v naught x is, remember, you have given d, the distance where the person is standing to the base of the building. Therefore, make use of that one. Therefore, say if I do like this, then I'm gonna say, okay, then my objective is I'm gonna go h must be equals to v naught along y times t minus half g t squared. To use this equation though, I must know what is the time. The next information, as I just said, what is known is, because it's given that the d is given, which I know of from the projectile motion, is v naught along x times the time of flight. And then I know now that the y component, the x component of the velocity, this one, is v initial cosine of the angle theta initial. I'm going to just call it, let me write, theta initial times t. You see, I know now this thing is given, this thing is given. Therefore, why don't I say this implies that my time t should be equals to d divided by this expression, which is v initial cosine of the theta initial. Therefore, this is the time. That means the time it took for this thing to fly all the way and strike that building must be the same as to this time that it took for the object to reach at the base of the building. This time is the same. That means that I have got my time. I'm going to just plug inside this equation. Let's do so. Therefore, I will say h therefore is, the height h must be therefore is the y component of the velocity. I know it's a v initial sine of the angle theta initial times this time, I now just calculated d over v initial cosine of that theta initial minus half the acceleration due to gravity g times that time d over v initial cosine of that angle theta initial square. This everything is squared. I'm holding. If somebody says stop, what are you doing there? I don't understand. I'll be with you. Please don't hesitate to interfere me. Then, if you are with me here, the initial velocity here cancels. One is on top, one is the down. Therefore, you could see now sine theta initial divided by cos theta initial is tan. You could see d is still there. D tan of the angle theta initial minus half of g d square is going to be d square divided by v initial square cosine square of that theta initial. That means this expression now is exactly what we are looking for. Any comment? YouTubers? Or those of you on the teams, do you have any? I'm holding on. Any question over here? Guys, that means you didn't understand. Oh. Uh-oh. Stop. Don't cancel. Am I audible? Guys can... Yeah. Thank you. I just heard a sound. Hopefully you're saying you're right. You on the YouTube, you guys who can't see me, but at least is also on YouTube. On YouTube, they can see me. The teams, you can't see me. I didn't because the camera is shared by the YouTube one, and I could not. I don't know if I'm allowed even to share the camera for two. Let me see. Can you even see me? I don't know, but I'm using this. Ah, good. Yes, sir. How did I get time? Oh, thank you. You see, the time it take, let me go back to the graph. Yep, yeah, the time is gonna take to reach all the way on the projectile motion up there is the same as to the time is gonna take to move this distance. Isn't it the same? This is conceptual though. Of course, you're gonna fire your stuff, which is a weather in this case. Therefore, it's gonna go, and then strike. That is all what you know of. Then you have to know that what is the time it take for the weather to start moving from this point to that point. Because I need that time to plug inside this equation, which is equation of motion along the y-axis. I need a time. To get the time though, I must remind myself, that's what I'm taking you to. In the projectile motion, along x and along y, the y component is given by this equation, and then the x component, the range r, is given by v naught x times t. You agree this one? Good. I'm going to bring also your textbook so that you could, just to convince you where I'm. This is your textbook that you'll be using. Maybe I'll go in and then I want to go into mechanics, okay, and then chapter 2. No, yeah, chapter 2, motion in two dimension. Where is it? It's here rather. What I'm basically pushing you is, if you have got a projectile motion, come. Yeah, this is where I wanted to go. The range, the x component, you always get this one. Yeah. That's where the x is equals to r. That's r is equal to v naught x times t. That's basically where I'm pushing you. Therefore, d is given. I'm going to go to second slide now. D is given. V naught x I know. Why? It is v initial cosine of theta I. The x component of the velocity is v naught cos theta I. I solve for t. This t therefore is d equals to v initial cos theta I times the t. Solve for t. T should be d over v initial cos theta I. That's where I got my time. Then I get that time, plug back into the h. That's where I am. All right? Thank you. Yeah, you're welcome. Then let's scribble in. Again, this is question number 6. Again, PHYV. By the way, that of question on FEVV is also interesting. It's a one-dimensional, but it's very good in terms of questions. I'll quickly go there also. Let's go into our question number 6. It says it's a projectile which is fired in such a way that its horizontal range, you see, is the same, we just in the same place again. Its horizontal range, I'm going to underline this one, its horizontal range is equals to 3 times the maximum height. And then the question is, how? What should be the, what is the angle of projection then? And what you are given is basically, you know the horizontal range is R. R is given, but it says the horizontal range is equals to, which is 3 times H max. That's what you know of. But it asks you, what should be the angle, the theta initial with which this thing is fired to reach such a thing? I don't know if I have this thing, but you guys, you know, on your book, yeah, here, you see, this is a sort of projectile motion it is talking. You see, the projectile motion depends on the initial angle. If you see here, if you fire by 15 degree, the range is going to be smaller. 30 degree, 45 degree is the optimum to get both distance as well as height in a, not height, let me rephrase. 45 degree is the optimum angle to send it far away. Therefore, if you go beyond the 45 degree, you see 60 degree will be the same as to 30 degree, 75 degree. The closest you come, of course, if you shoot up, the height must be maximum, but the range is going to be 0, obvious. Then the question asks us that, with this given condition, what is the initial angle with which this thing is fired? What do you give me? Where are you going to go? And okay, let me also, if just to give you a hint, remember, I don't need to derive this equation. The maximum height, by the way, you could use this expression. This is the maximum height. The derivation is very easy. At the maximum height, velocity 0. From the velocity 0, you get time of flight, time going up. This is the time of A. Time of flight means how long it took to reach the maximum height. And then the same time is required to come down, obvious. If you call this one is a time TA, and that time TB, TA is equal to TB basically. Go through that one, TA is equal to, from this simple expression, V final is equal to V initial minus GT. At the maximum height, that's the main one here. At the maximum height, velocity is 0. Therefore, V initial sine theta minus GT is equal to 0. Solve for T. You see that the time of flight to reach the maximum height is V initial sine theta over G. If you plug that one into the Y expression, Professor Tim must have done with you this one, then H is given by V initial square sine square of 2 theta over G. This is the maximum height. In the same scenario, if you know of the time of flight to reach from this one, and then that one twice of TA, you have the whole time from along the x-axis. Basically, the time it takes for to fly from origin means from where it is fired, to the point where it is landed is twice of TA. It's a double. TA, another TA, therefore twice of TA. If you plug that one into the equation and rearrange, the maximum displacement, the range, we call it range, is V initial square sine of 2 theta. Remember that sine 2 theta comes from sine theta, 2 sine theta cosine theta is equal to 2 sine theta. Prof. T must have proved for you. We will be using these two equations. V initial square sine square 2 theta over G for R, and then another equation here. If I put these things together, therefore, I'm just going to rewrite it. From the given equation, R is equal to 3y of H max. But I just showed you on that expression, then I will say R is V initial squared sine 2 theta over, this implies, I better say, this implies over 2G, that is for R, must be is equal to 3y of the h max is, remember it's a v initial square sine square theta initial over, if you are confusing where are you getting this expression, I'm just writing this one. V initial square sine square of theta initial over 2g for h, and then I'm simply multiplying by 3 this expression. For r, I simply wrote that expression. Therefore, you should be aware of what I'm doing. Over that expression is also over g. Then if you rearrange this one, what do you get? Oh, let me allow somebody's on the waiting. It says, is it? Okay, I'll check. I hear some noise though. Somebody chatting. Oh, on the YouTube. Oh, okay. Yeah, I'll go back to it. Okay, let's go then. Now that's the equation that we'll be having. What do you say then? Simply, you need to rearrange this one. If I rearrange, what do I get? Let me take my pen. Then g will go. Then v initial squared again to go on both sides. Then sine 2 theta over sine square theta must be equals to, that is, I'm taking the other one, 3 over 2. You see, basically this is a just simple algebra, I believe. Then what is sine 2 theta? Oh, I forgot. Sine 2 theta is 2 sine theta cos theta, I believe. Isn't it? I believe so. Let me say 2 sine theta cos theta must be equal over sine square theta. There is theta initial, by the way, everywhere. Must be equal to 3 over 2. Then rearrange this thing. What do you get? Therefore, this is my mathematics now. I must remove one sine square will disappear with that one. Then I will get 2 cos theta I over sine theta I is over tan. I'm going to call it tan theta I must be equals to 3 over 2. If I rearrange this one, sorry, I don't have a space now. I'm going to just use this small area left inside this. Therefore, I'm going to say tan theta I must be equals to, if I take that one, is going to be 4 over 3. Theta I must be tan inverse of 4 over 3. What could this be? Which should be, I think I had, yeah, 4 over 3. If you see, this angle is 53.1 degree. I'm just taking the answer from the equation itself, because I could see here, the answer is 53.1 degree. Should be clear. Basically, what did I teach you here? Let's basically understand the equation. It says it's a projectile which is fired in such a way that its horizontal range, which is r, is equals to 3 times of the maximum height. Then remember, r is given by okay, checking my comment on the YouTube also. Guys in the YouTube, please don't hesitate. Those of you who are following, you could ask a question also. I don't think you could communicate with me by calling, but I'm watching your chat. You could ask a question on the chat. Okay, therefore, just to pop up back again, the h must be, r must be v naught square sine 2 theta over g, and h max must be equal to v naught or v initial square sine square theta over 2g. This one has with 2, that one has no g. If you know these two equations and then plug it into the given expression, which is r is equal to 3 h max, you simply get the angle with which this projectile fired must be 53.1 degree. Should be straight and easy for you. Happy? I'm expecting, if you have any challenge, stop me. And now question number 7 is kind of a circular motion, I believe. Isn't it? Yeah, it's an athlete that rotates a 1 kilogram discus, I like it, along a circular path. If you think of it, if you know how to play this thing, you hold it by your tip of your finger, and then you must be stretching your arm out. Your arm is about 1.06 meter basically according to this one, and then you will be making a circle if you think of how to play this discus throwing, or for that matter, or any like discus, easy simple example. Therefore you should stretch your arm as much as possible, hold, because that the arm length also matters, 1.06 meter, and then rotate at high speed. If you release it, it will fly. Says an athlete rotates 1 kilogram discus along a circular path of radius given 1.06 meter. The maximum speed of the discus is 20 meters per second. It's the velocity with which it's going. Determine the magnitude of the maximum radial acceleration of the discus. This is basically, remember, a circular motion, and I don't know, it looks complicated, but it's actually easy. If I think of, I forgot about that particular person, let's assume it's just an object undergoing a circular motion. This is that object, then there is an arm length, that's the arm length R, which is given, and then this thing is rotating at certain speed, it must rotate to release this thing, or at certain point if you release your hand, meaning the tension is cut off if you are thinking of a pendulum, and then it should fly. And what is acceleration for such thing? For particle moving in a circular motion, I hope you remember there are two things. Tangential acceleration, which is to do with tangent component of the acceleration along the circular path, is tangential, as the name implies. And then there is a radial acceleration, which is center seeking, because of the object is connected to your arm at that instant. Therefore, we are interested in the center seeking, which is a radial. Always the acceleration is inward, which is a radial component. For such motion, therefore, what you simply remember is A radial must be equal to V square over R. This is acceleration is a vector. I must be careful here. Therefore, it's a center seeking radial acceleration. This is basically what it is requiring you. I believe this question is supposed to be easy. I don't know why it is there even. What do I have? V is given. Mass is useless. I don't use the mass. And what is 20 squared? Is 400. 400 divided by 1.06. 400, I'm just making. Oh, no. V square is a 20 squared is going to be 400 divided by 1.06. Then what could I get? Let me get my Excel. I forgot everything. What is this one? Divide is equals to 400 divided by 1.06. It should be, and then 377.36. That's what Excel is spit. 377 point. What did I get? 36 meter per second square. This is what I'm getting for A radial, which is true though. Yeah, 377 is happy. Should be easy, guys, and otherwise I will be undermining your understanding. This is basically, the question is to understand what the question all about. It's an athlete that rotates up this much discus. In this, the mass is useless here. You don't need this information. But what you need is the radius. This is a radius of 1.06. The maximum speed is given 20 meters per second. It's asking me radial acceleration. I know that A radial is V square over R. V is given 20. 20 squared is 400. The radius is 1.06. I just did it here. The answer should be straightforward. I don't know. I left the empty page in case somebody asks a question, but this is straightforward though. Let's go. I will spend a lot of time on the FEVV. There is a nice for you guys for the PHYV student also. The question I will be displaying from the FEVV student is quite good, even though it's one-dimensional. Here, maybe should I a little bit wait? If there is, the YouTube is still slow. It's behind the where we are. They are just starting question number 7 on the YouTube. How slow is this? Pooh. too far. Okay, let's read anyway. Question number 8. It's an athlete that swings a ball. Again, this one is kind of a circular motion. It swings a ball, basically like a discus, connect to end of a chain. He has got a chain in a horizontal circle. The athlete is able to rotate the ball at a rate of 8 revolutions per second when the length of the chain is 0.6 meter. When he increases the length of the chain to 0.9, he is able to rotate the ball only by 6 revolutions per second. Which rate of rotation gives the greater speed for the ball? Oh, that's good. I didn't read this question thoroughly. I just pasted it. I need to think about it even myself. Please help me in thinking. Kind of let me put. It is, let's think of like a table, circular table. Let's think there is a hole through. And then there is a chain. I can't draw now 3-dimensional. There is a chain that is going to be connected to this ball. Let's assume that this thing is hanging at the bottom. Then this guy must be holding it here. He could pull or push and then rotate it. When this thing is, it says, an athlete swing a ball to an end of a chain in a horizontal circle. This is a horizontal. The athlete is able to rotate by some hook or means, okay, the ball at a rate of, therefore it's going to rotate, like make a circle, It's going to make a circle, and then the corresponding radius, it says when r equals to 0.6 meter, the angular velocity, which you could see now, this is a revolution per second, therefore this is kind of omega, I believe, because it's a rotation. Then revolution per second, he can make 8 revolutions basically in 1 second. That's omega, let me call it 8 revolution per second. Omega at 1, let's call it R1, omega 1. And then again, what he did is, when he increases now, he releases this holding. The length now at that time, let me call it, my radius, my table is small. I'm going to make the table a bit bigger. I'm going to bring the table, I thought process. Let me make it like this rather. Then the hand is going to be outside. Then the guy is pulling it from there out. That is the first drawing. Then in the second round, he now released it. Then the distance now increased to 0.9. Then it's going to undergo again another circle. But this time, let's call it omega 2. When R2 is equals to 0.9 meter, the omega 2 becomes 6 revolution per second. That's what you know of. The first one, when the radius is 0.6 meter, the rotation is 8 revolution per second. Then they release the and then make a big circle where the radius is 0.9, but he managed only to get 6 revolution per second. That's all what you know of from the information. The choice or the question that is coming, I'm reading about this one. It says, which rate of rotation gives the greater speed for the ball? What is the centripetal acceleration, which is v square over r again? Centripetal, center seeking, radial, all the same. What is the centripetal acceleration of the ball at 8 revolutions per second? What is the centripetal acceleration when it is rotating at 6 revolutions per second? And the answers are given. Before even we go into the answer, let's go in. How do you go around? Does the question make sense for you? Are you happy with the way I kind of split the question? You need to visualize what I'm talking here. Think of a horizontal table. There is a hole at the center of it, and then the ball is hanging in a certain way. Without touching the table, you making a circle. Then the revolution at that time, when r is equal to 0.6 meters, the revolution is 8 revolutions per second. That's 1. 2, when now the length is increased to 0.9 meter, higher radius, the revolution becomes 0.6 revolution per second. The question they ask us is, what's the rate of rotation? Which rate of rotation gives you the greater speed, V? By the way, I don't know if it derived for you in the class. In such a condition, do you know that the V is equals to omega R? I don't know. Somebody correct me if you know about it. The linear speed V is equals to omega R. Do you know this? Good. Then, by the way, we could simply go into either use this one, that this expression, V is equals to omega R. What is the rate of if you just do for me, therefore for the first one, for R1, this implies that V1 must be, I'm just trying to get, I don't know if this is correct. Let's see. V1 should be, omega is 8 revolution per second. R is what do you get? 8 times 0.6. What do we get? I don't know. My head is tired. Not today, long time ago. I used the calculator. Yeah? Somebody? 4.8. Let me write. I'm going to trust you. 4.8. Let's call meter per second. I can't make. Yeah, revolution meter. Let's say meter per second. What about V2? Six times. 6 is going to be 6 times 0.9. Somebody tell me. 5.4 meter per second. Which one is big then? Easy, we could answer. What rate of rotation gives the greater speed? Therefore, the second one. Happy? What did he say? What is the answer? For 8 revolution per second. Oh, he got, maybe you see the answer is here. You know why? I jumped actually. Revolution per second. I don't know the distance. I must be careful there. Look, to answer the question, you could easily see that, yes, the bigger one, therefore the 6 revolution gives the greater speed of the ball. I know for sure that's the answer. This also says 4.8, 5.4. The unit is wrong though. I should be working through. Let's work properly. The answer is correct. But to work through, let me go like this. Then from revolution per second, I must get the time first of all. You see, I shortcut actually. Don't do what I'm doing. The correct way is therefore, we know the revolution from 8 revolution per second. I could see this means the time t is equals to, remember revolution is basically, it revolves 8 times in 1 second. T should be 1 over 8 second. Therefore, what is 1 over 8? 1 over 8 means 0. Guys, I'm tired in my head. I think 0.125 kind of. 1 divided by 8. Yeah, I think second. That's correct. Therefore, for the 6 revolution, again, do me guys, help me. T should be 1 over 6 second. Therefore, it should be 1 over 6 is 1 divided by 6 is fast. 0. Let's stop there. Second. Thank you. And then we know now that time. Then let's calculate properly the speed. The speed is actually, think of it, if you are careful, don't do what I did at the beginning. Remember, it's going to revolve from this point to make a circle. The distance it move actually is, you see, it's a circumference of the circle. Do you agree? The distance S, or let's call it D. The distance this ball move in this second, D is 2 pi r, which is equals to 2 times 3.14 times r is, at that time it was 0.6. Yeah. What was the time? Yeah, 0.6. Yeah, 0.6. Give me what's the distance? Somebody using a calculator? Or I could do for you now. 2 times 3.14 times 0.6 give me 3.77, guys. Yeah, thank you. And then I know D, I know T. Therefore, the speed V must be, what is that equation? S is equals to V in, V is equal to, remind me. I'm forgetting a definition. Definition wise, I'm coming. Velocity V is equal to distance travel, S over T, which is D over T. In this case, therefore, V should be 3.77 meter divided by, what is my time at that time? 0.125. What is it going to be? I will do for you, don't worry. This equals to this one divided by 0.125. The answer is 30.14. Therefore, 30.14 meter. You see? Meters per second. This is speed. This is correct. You could see that Professor Tim also put for you for 8 revolution per second, the speed is 30.2, which is exactly what we get it. For the other one, do exactly the case. Where is my tablet? For the other one, I finished my table now. Happy up to now, the same thing though. D is gonna change for that particular. Therefore, it's gonna be 2 times 3.14 times R is now 0.9, and then I'm gonna redo it. Is equals to 2 times 3.14 times 0.9. This time is going to be 5.652. This answer is 5.652. And then if I divide by this one by the time you guys gave me, 0.166, which equals to 34. And the second one, this is V1. I got V2 to be 34 meter per second. You see, you could clearly see my rough calculation as well as my real calculation give me that the one that moves at higher distance actually moves faster. Obviously, you could see. Basically, if you are rotating in the inner circle, you don't need to run faster. If you are rotating on the outer circle, basically, of course, you have to run fast to cover with a very short period of time. But it also depends on the revolution. You answer A, therefore we know this is a rough estimate, but it takes us to the same answer though. We know that when it is rotating at 6 revolution per second with 0.9 distance has got the highest speed. What is the centripetal acceleration of the ball? I don't need to do this one now. You guys do it yourself or easy. V, we know V. Now we just calculated V. I'm going to say A centripetal, which is a vector, is V squared over R. You know the radius for both of them. The first one is 0.6. The speed is, we get, what did we get? 30.2 meter per second at that time. The radius is 0.6. You insert in this one, you must be able to get whatever answer is here. Let's do one, for example. What did we say? V square is, I'm going to go into the Excel. V square will be that one. I will say this one, this square divided by R is 0.6, 0.6. This must be the answer. 1.514 times 10 raised to how many? 1, 2, 3. 5.514 10 raised to 3 meter per second square. That should be the answer. Yeah, 1.52, which is basically what we said, 1.52. If you see this one, if you want to check format, I will say scientific. Where is she going? Scientific. You could see 1.51 times 10 raised to 3 meter per second. That's all right. It's easy though. If you know the formula, centripetal acceleration is V squared over R. Make sure you calculate V properly. Divide by the radius. You must get that one. For the second one also, what matters is the speed. The speed is a 34 we get. The radius is at that time 0.9. Put this thing together. You must be able to convince yourself. In that case, it's 1.28 times 10 raised to 3 meter per second. You see, this one, the acceleration for the second case is slow, even though the speed is high. This one is acceleration is fast, 1.52 times 10 raised to 3 meter per second square. What do you say? Those of you PHYV, this is what you are up to. Thank you. Yeah, any? Somebody on Teams, you want to say? Thank you. Just before you go, guys, even though it is not your part, I'll be working through the, not you, I'm gonna close this one. The questions from the FEVV student is a very good questions are down there, by the way. And I am interested in, for the FEVV, in a sense, Dr. Lindsay, if I take you what I'm talking is, her name is Dr. Lindsay, and she wanted me to discuss with them from section 6.4 to section 6.5. I find it interesting, the question, even though it is one-dimensional. If I take you 6.4, this is where she wanted equation of motion, one-dimensional. There are questions here. Question number 2, 3 were especially good. And the free fall, two-dimensional again. I like her question here, especially here. Number 4 and number 5. Conceptual question with a calculation though. She always give answers at the bottom for a student to check if what they are saying is correct, to compare, but the workout is not there. Therefore, I'm going to spend a bit of time. Those of you on the PHYV, if you are interested, you could stay with me, but if you, as usual, if you might be busy, you are an engineering student, I would imagine you must be busy with other courses also. If you run out of time, you may go, and happy with you. Thank you for joining me this morning. If you have time, it will help you though. I'll be happy if you join me also. And this thing is on the YouTube. It is directly uploaded as we speak. It's alive. Somebody who is watching on the YouTube also will get it. I hope you guys know where to go on the YouTube. We are Yebo Physics. If you go to Yebo Physics, you simply click on the videos. You will see every day. For example, that of today is motion in 1 and the 2D. Our discussion, our short, everything will be available there. You could watch other time also. If you continue with me, happy. If you not, have a good day. And let me just cripple through what these questions are. Question 3.4, this section that I will be discussing is one-dimensional, not 2D. She wanted two-dimensional is down, but it will be discussed tomorrow on. You see, this is a motion two-dimensional in section 7 that will be discussed by Lucian as well as Arnold, I believe. Yeah, mine today will finish. By the way, those of you FEVV student, PHYV rather, my course will be in second semester. I will be your lecturer second semester on the PHYV 102. I'll see you that time in person. Now we will together, I will continue as a tutor with you for this session, but the second semester I will be your main lecturer for the PHYV 102. Hopefully you will pass this one and then you will join me on the second semester. That one, have a good day. Let's go into this one-dimensional. Basically, you guys on the FEVV, when you watch this video, you must read through. I'm not going to read. And then, of course, she has indicated to me and to you also. Remember, when you are talking with free fall, we avoid air resistance. But it doesn't mean that air resistance does not affect. It does affect. However, to solve the problems, we simplify things. You don't know what is the resistance of the air. Difficult to quantify. Therefore, we always ignore it, but don't ignore in the real life. And sorry, I'm kind of getting tired, I believe, and I've got a bottle of water. And what this table in front of me is telling you basically, look, it's a free fall. If it is a free fall, nothing happening. If you release, the object will accelerate. With what? With acceleration due to gravity. What is acceleration due to gravity? 9.81 meter per second square. Always down. This gravity is always down. If an object is going up, therefore don't forget to use a negative in front of the half gt square, because the gravity always pulls it down. That's mainly what I need to specify there. And then if you go into these equations that she wanted me to go through, is Question number 2, for example, says, I hope everybody sees this one. Those of YouTube, it is too slow. You are still watching FVV equations. Yeah, maybe it's coming back to you slowly, but it will come. It says, those of you on Teams, you could easily see what I'm reading. What assumption do we make when applying the equation of motion for free falling object? The answer should be, we are assuming that the air resistance is negligible and we avoid it, and that the acceleration due to gravity is 9.8 meters per second square. Always it is down to the center of the earth. That will be the assumption that you make. With this assumption, she gave a equation. She said, calculate the displacement and the velocity at the time t equals to 1 second for a ball that is thrown vertically upward. I think I need to open my, I'm going to open this equation on my tablet so that I will be with you. This is page 8. That's where I am. I'm coming with you. Page 8. No, not 9. Page 8. And then I'm going to zoom it small. And sorry guys, I'm going to display, on my tablet. Therefore, I can write on my tablet. That's what you see here. Even though looks small here. Let me make it. Yeah. You can see. Yeah. It says calculate the displacement and the velocity at time t equal to 1 second for a ball that is thrown straight upward with an initial velocity of 15 meters per second. This should be straightforward. It should be easy for you, for the engineers as well, for the PHYV student. Then basically it gives me that this ball is going to be thrown up. I must remember the acceleration due to gravity always pulls me now. Therefore, G is down. It has got initial velocity, V naught, which is equals to 15 meters per second. And then it tells me that this thing goes in flight for 1 second. It will be going somewhere there. And then she asked me, what is it? Calculate the displacement. She asking me, how far do you think this ball will reach up onto the sky? If it is me, if you had a good formula inside you, I'm simply going to say that y is the displacement, is the x is the same as to x. In this one is vertically up, therefore let me call it y, must be equals to v naught times the t minus, that is a central point you need to remember, half g t square. Why I make half? Because this object is moving up, but the gravity is always tagged to it and it's pulling it down. I must use this, minus should be there. Then if you put this into practice, therefore 50, that meter per second times the time is 1 second, is going to be 50 meters, minus half, G is 9.8, I'm going to use 9.8, T squared is 1, therefore what do you get? Therefore this is 50 meters minus half of 9.8 is, let me take it 10 point something. The answer should be 10.1. You see, I could see. Therefore, 9.8 divided by 2. You guys do it yourself. This is all in meter. This is also in meter. Therefore, 10.1 meter. I'm cheating actually. I'm seeing the answer there. But I could see this is 15. If I take 9.8 as 10 divided by 2 is 5. 15 minus 5 is 10, because I'm losing a small number, divided by 2, 0.2, which is 1. Makes sense. But I'm not, this question is actually easy and wheezy. Let's go. What it says? What about, she say, take the point of release to be this one, and then what else she has? Calculate the displacement, and the velocity at time this one. Oh, it's not final. I thought the ball is going to reach it. It's on its way though. It is still moving. What would be the velocity when the corresponding time is 1 second? What you would have done, easy for me, I'm going to say V final is equals to V initial plus GT. But I forgot that gravity is negative. I must be careful. Therefore, I'm going to put this one as minus GT, which is equal to 15 meters per second. Minus G is 9.8 meters per second square times T, going to be 9.8 meter per second. Then it is too little now. What is 15 minus 9.8? 15 minus 9 is going to be 6. 5 point something, 5.2. What is the answer? 5.19. Yeah, around there, 5.19 meter per second square. This should be the short answer. Okay, those of P12 also hanging with me. Guys, if you have any comment or question, you're welcome to say why, what are you doing, why you say so. I believe that is straightforward. Rather, I find this one kind of, I just read through before I started this presentation. I thought of, oh, it's good. Good questions are there. Let's see question number 4. It says the following. Calculate the height of a cliff. It's not descriptive. What sort of cliff is it? Calculate the height of a cliff if it takes 2.35 seconds for a rocket to hit the ground. I don't know. Let me try to picture what she is trying to say. Let's say this guy is just standing just on the edge of the cliff and then must have thrown a ball up a cliff at the, and then it says if it takes 2.35 seconds for a rocket to hit the ground. Oh, okay, it must reach the maximum height and then do, and then it's gonna go pop here. It must land there. And then the time of flight from here to reach there, the maximum, and then all the way, T total is 2.35 seconds. That's what I know of now. And then she said to hit the ground when it is thrown straight up up from the cliff with an initial speed of, oh, okay, thank you. She gave me a speed with which it is moving. When it is starting from here, it has got 8 meters per second. The initial speed with which it was tossed up is 8 meters per second. The A asked me, oh, what should be this height then? Oh, it's a lot of thought there. What is the height? 1. 2. B says how long a time would it take to reach the ground if it is thrown straight down with the same speed? Oh, okay, we'll walk there. Let's first of all, where should I go? Kind of short, I've got a short hand. Where should I go? I've got initial velocity. It's gonna go all the way up. It's gonna reach its final, V final. But I know of, for such object, the final velocity must be 0. Of course, you know, if you throw something up, it go as much as it can because gravity is pulling it down. It will reach a maximum height. At the maximum height, the velocity must be 0. I know of that one. Good. And then it's going to go all the way now. It has to finish whenever it go up to come to the edge of the cliff, pass the edge of the cliff, and then bow on the ground. How do I know that? What is the height then? The height must be to do with, oh, okay, I think I've got idea. What do you say if I got the following? I'm going to first calculate the time it takes from this ball to go from here to here. Let me call it T1. And then the same time is going to take it to come down here. Let me call it T2. T1 is equal to T2, obviously, because the time it takes it to go up is going to be the same as to the time it come to down. But we are talking only up to there. Then the remaining time will come here. Let me call T3. If I know T1, that means I knew T2. If I know T2 and the T1, which is double of T1, I know the overall time. I'm going to subtract that overall time from, I'm going to subtract twice of T1 from this one. Then I know T3. If I know T3, I know the velocity at this point, by the way. You know why? If an object moves with 8 meters per second at this spot, reach maximum height, when it is coming down exactly at the edge of the cliff, is going to have the same speed as 8 meters per second. Ask me why. Energy neither created nor destroyed. Because if it was 8 meters per second moving up, air resistance is, we could increase or decrease, but it doesn't matter. The same air resistance is there. The same air resistance is down. The same energy must be back here. I know, therefore, when the ball is at that spot but moving down, it's going to have the same speed, 8 meters per second, going down though. Therefore, if I know T3, I could get H. That is my strategy. Do you agree with me? Is it a good? Let me repeat what I'm saying. I'm saying I've got 8 meters per second initial velocity. I know the final velocity is 0 because when it reaches maximum velocity, the maximum height velocity is going to be 0. Using V final and the V initial, and then knowing the gravity is down, I must know time T1. If I know time T1, the time it takes from up is the same as the time it gets down to cover up the same distance. Then I know that the overall time. If I know that overall time, I'm going to subtract it from 2.35. Then I know my time T3. If I know my time T3, I know the initial velocity when it is just passing the edge of the cliff downway. Then I use that initial velocity. I've calculated the height edge. That is the target. That's my strategy. You might go any other way, by the way. It doesn't mean that what I'm saying is the only way. It could be any other. Do you think it's a good plan? Let's go for it. Therefore, in doing so, I'm going to say V final, when it is at maximum, must be equal to 0. I know it should be equals to V naught minus GT. Then, from this expression, I'm going to say, then the initial velocity is 8. 8 must be equals to, take one to the other, G times the T. Therefore, let me call this one T1. To fly, to go from that point to this point. That is my T1. This is my T1. T1 must be therefore 8 divided by 9.8. What could be it is? And let me go here. It's equals to 8 divided by 9.8. What do I get? 0.816. Let me say this one T1 is 0.816. I know T2 is also the same. This must be 2 times that one, equals to 2 times the same time, that time. Therefore, I get 1.632. T2 also, T2 is the same as to T1. Then T2 plus T1 rather. T2 plus T1 must be twice of 0.816, which is equals to, I get 1.63. 1.63 enough 33 maybe second. Therefore, the time T3 must be equals to, T3 must be the 2.35 minus 1.633. Then if you do this, I'm just gonna do on the Excel, what I say, 2.35 minus the time I put it here, 0.72 meter. Not meter, man. Second. Check. I believe. My stuff is good. You know, even there is a question here. It says, hey, I could see the answer there. I'm cheating. My strategy must be good. How long a time would it take to reach the ground if it is thrown straight down with the same speed? You see, I told you, is going to be moved up with 8 meters per second, reach maximum height. When it come on its way down, it's going to have exactly 8 meters per second. Down though. Therefore, the time T3 is, in other way, we have calculated T3, 0.72 second. Correct. Therefore, we know time T3. Let's go back to H. How do I do for H therefore? H must be, then that H is V naught times T. I know the time T3. Plus now, you might ask, why you say plus now? Because the acceleration due to gravity is down. Half GT squared. Then, let's see. Therefore, 8 times 0.72 plus, my plus looks like times, plus half 9.8 times 0.72 squared. I'm going to do it on the Excel. Therefore, I said this one equals to 8 times that time, V initial times T, plus half 0.5 times 9.8 times that time squared, which is equal to 8.26. I got 8.26 meter according to my calculation. But it's not far off though. Maybe she used gravity. I don't know what she used. The answer she said 8.29. I don't know. Maybe 2926. Maybe I'm not using 81. Maybe did she use gravity 9.81? But the answer is very close. Happy. That is almost the same as to that one. Therefore, don't you find this thing kind of interesting? Because it's the question itself is a little bit stuffed together. It's not that much expressive. You see what I mean is, if the cliff is too wide, you could think that, oh, how is the ball gonna miss or the stone gonna miss? It's gonna hit the cliff. I'm making in such a way that the cliff is so thin that the person is actually standing on the edge and then throwing up. When it is way down, it just misses the cliff. I put that one into equation. I cut into pieces. I've got three distances now, going up, going down, reaching the same height as before, moving down. I ended up getting the answer correct. Agree? Disagree? I'll be happy if you say I disagree with you. There is a short way to go. Why didn't you use this method? I will be happy with you if you guys comment. Happy. If not, I'll be going into the second one a little bit again. Yeah, you're welcome. I wish you asked me this question a long time ago. I haven't recorded with the YouTube. I didn't record on our Teams. I would have. You're supposed to. You're supposed to come long time ago. Now should is it? I'm gonna start recording. What is that thing? Shit. More recording. Start recording. SX, you also Caesar? You have a question? Somebody raise hand. I didn't see you long time ago. Caesar? Oh, sorry for the recording. Yeah. Remind me. Yeah. Yeah, I understand. Look. Sorry, man. I supposed to know this thing a while ago, but in the future I know now. But the good thing is, it is recorded directly on YouTube. It's live actually. You will get if you if you go into our YouTube, which is a Yebo Physics, and then scroll through the motion in 1 dimension and 2 dimension. Of course, you could see with the when the recorded was happened. Actually, it's recorded on YouTube. You will get it straight forward. You're welcome. Yeah, good. Thank you for interfering me also. Please, guys, don't hesitate. And I've been in this kind of Yebo Physics now my third year, but at the university I've been 21 years. You can see how old I am. Therefore, I don't have any problem if you interfere with me when I'm discussing something. If you say, no, I don't understand what you're talking there. Can we discuss in that way? Can we do this way? I am more than happy to work with you. Therefore, please don't hesitate to ask any question. And let's go back to our FVV equation. This is a motion in 1 dimension, but nicely for those of you PHYV also, this thing is useful. Let's see, question number 5. That's where we are now. I'm gonna zoom a bit so that you could see. Yeah, those of you on the Teams, you must clearly see. This kangaroo, according to the lecturer's question, a kangaroo can jump over an object which is 2.5 meters high. That's all what we know of. I hope it's not jumping like a projectile. Is it going only up, or is it projectile? I don't know at this stage. But it's written there. Considering just its vertical motion, let's assume the kangaroo is not horizontally jumping. She is. Let me make it her. She's a girl, a lady kangaroo. What is it called? I don't know even the name. If it is different name. Okay, she's gonna jump up. Let's say, just simply vertically up. She said only consider the vertical motion. Considering just vertical motion, calculate its vertical speed when it leaves the ground to have 2.5 meters high up in the space. I say in the space, in the air. And let's forget about the kangaroo. Let's say, okay, this thing is going to be thrown up, but we know of is going to jump off the height we are given is 2.5 meter. That we know of. And then it's we don't know with what velocity v naught is this thing jumping. But we know of something, it's a hidden. When it reaches the maximum height, always remember this one, v final must be equal to 0. That's why it could not move beyond 2.5. The velocity is finished. Then with this information and the simple formula that is in my head, I could say that the v final is equal to v initial. What am I looking for? How long a time is in the air? And then considering just the initial velocity, I will find a time. I must find how long in the air, going up and come down. Okay, these two. Where should I go? I'm going to say v final. I don't know where I'm going to take me. V final is equals to v naught minus gt. I must remember. This one will give me the time. The h, I'll go back to it. This is for b. I must remember negative because the acceleration due to gravity always pulls you down. That's why this guy cannot fly to space. The gravity is targeted to it, it's pulling it down. Gravity is what causes for it to happen only at 2.5. Okay? Therefore, I know this thing is 0. The initial is and now I'm stuck here. Therefore, the time t should be v naught divided by the gravity g. Let me leave this one there. I will go the other route because I don't know the v naught itself. What should I use? You could use different formulas. What do you suggest to me? Can I use this one? Somebody's on the Teams. Why do I need to admit? Okay, I'm gonna stop here. Anybody on the Seha? On a Teams? Somebody's waiting. I don't know why. Did I lose contact with the Teams? Okay, somebody's in already. Okay, anyways, let's go. What should I use? You have so many equations, by the way, to look for. How do I go h? H, for example, h is equals to v naught times t minus half gt squared. Where is going to take me? I don't have time. Therefore, I shouldn't use this equation. I'm just taking for you how far can you look for. What's the formula to use? What if I use the following? Then v final square is equal to v naught square minus 2gs. What about if I use this equation? It should be. You know why? I know what I'm looking for is h. The h is the same as to s. I got h. Then v final, I know it is 0. But I'm looking is v initial. Therefore, can I say v naught square must be equal to, I use negative because remember, acceleration due to gravity always pulls it down. Must be equal to 2gh. I know my h is 2.5 meter. Then from that, v naught must be the square root of 2g times h. What is that? The square root of 2 times 9.8 times 2.5. Let me go get on my Excel. Therefore, this one should be equals to SQRT, that's the square root. I'm using Excel as a calculator. What is the equation? 2 times, not plus, times 9.8 times 2.5. 2.5, which equals to 7 I got this one, the initial is 7.03. Let me say, what did she say? 7.03. You could see 7 meter per second. Good, initial velocity. I will go back to my time now. Therefore, my time should be this one, the velocity divided by 9.8, which I get 0.72. My time is 0.72 second. You see? Let me check if the answer is correct. Yeah, 0. What's the answer? I lie. I got it wrong. Check what I've said. The time is 0.72 second. What did I miss? I wish you guys, where is my engineers who was online, who told me? What did I miss? I calculated the time, t is equal to v naught over g, and then I got my v naught, I put into equation, I divide by g, and then I got 0.72 second. But I forgot something. What did I forget? This time, if you are, okay, oh, come on, it's gone. I'm gonna reopen, bad. Yeah. This is bad working with tablet. I lost everything that I did, but it has been recorded. Don't worry. It has been recorded. I'm gonna go back. Where is my kangaroo? This is about the kangaroo. I forgot when I was working here, if you remember what I did, this is 2.5 meter. It's gonna V final is equal to 0. I calculated the time t going up, t up is 0.72 second. I forgot that the question actually says calculate just how long in air. What that mean is going t1 up and then another t down. Therefore, I'm supposed to multiply by 2 because it's a double. Going up is 0.72, coming down is also 0.72. 0.72 plus 0.72 something. There is an error in calculation. 1.43 second is the final t total. Actually, I only calculate the one way when I get 0.72. FEVV, once again, must have left now. I finished with SPV. I'm also getting tired, I believe. I'm gonna go into, where is this one? Section, I'm not supposed to go there. Where is Dr. Lindsay's other question? I calculate 4, 6.5, 7. I don't want to go into 7. 4, I calculate this, I calculate. Did I finish? Oh, I go upside down. I actually started. Hey. Me. Yeah, I'm supposed to do this equation first, but I go to, where did I go? I started here, 6.51. I've gone through this one. I supposed to start, guys. FEVV student, sorry. I'm supposed to start there, but it doesn't matter. I finished here. I'm gonna go back to this one. This is basically for FEVV student. I was supposed to start here, equation in one motion. 6.4. Let's work through. Question number 2, that's where I'm gonna start. Basically, read through that one. Let's go with this question number 2. It's a freight train can produce only relatively small accelerations, you say. What is its final velocity of a freight train that accelerates at the rate of this one for this minute, starting with initial velocity of that one? I think this, I know now why I passed it. It's very simple. You are given, V naught is given, which is 4 meters per second, and then its acceleration A is given at is 0.05 meter per second square, and then it moved for a time of t. Remember this one? This is basically to teach you, please convert always. Whatever time is given, or any other matter for that matter, convert to its corresponding SI unit. That's the main one. 8 seconds, therefore 8 minutes. I'm gonna straight convert into 8 times 60 seconds SEC. Then I could work from this on. What is the final velocity? Easy. I'm gonna say, okay, what are you talking? Then it is simple. If you know of V final should be V naught plus AT. Acceleration is given, time is given, P naught is given. Therefore, V naught is what is that? 4 plus, forget about the SI unit now. I know everything. half 80, A is 5 over 100. I'm just watching there, times 8 times 60. If I'm lazy now, I start getting tired, this 0 will go by 2, 5, by 2 is going to be 4, by 5, 1, that 5 also disappear. 4 times 6 is 24, 24 plus 4 is 28 meter per second maybe. What is the answer? Yeah, easy, 28 meter per second, and it should be straightforward. This is very simple question though. Yeah, B, if the train can slow down at a rate of this much, how long will it take to come to stop? This one is a bit information. Now acceleration is no more, by the way, I'm supposed to put vector everywhere. Acceleration is deceleration rather, is the minus 0.55 meter per second square. It's a decelerating now. How long? I should be looking for a time. How long it says? Looking for a time to come to stop. Oh, you see, V final is also 0 because it's come to stop. From this velocity, it's also given to me that from this velocity. What that means is, please careful there. This velocity means the velocity we just calculate, the final velocity, which is V initial now is 24 meter per second. That might be a tricky to say that it's a decelerating 0.55 because it's slowing down. 2, I'm looking for a time, how long it takes. You should be careful there. Again, it comes to stop, V final is 0. From this velocity, which velocity are we talking? Not the 4 meter per second, rather the final velocity we just calculated, which is 28 meter per second. Therefore, I'm looking for a final, the time. Don't I use basically the same formula around, saying that the V final must be equals to V naught plus 80. Therefore, the final is going to come to rest. Then minus V naught is equals to minus 80. You could see I'm calling it negative because it's a decelerating. I'm using that formula there. The negative will disappear. Therefore, the time must be equals to the velocity, which is 28, divided by the acceleration, which is 0.55. What do I get? Let's check again. It should be equals to 28 divided by 0.55. The answer must be 50.1. What did she say the answer? Yeah, 50.90. Oh, we exactly get 50.9090. Let me call 50.91 rather. I'll take a kind of 50.91 second rather, not 90, but just exactly the same what she's saying. And then she says, how far will it travel in each case? Now we have to find a distance here. We have to find a distance there. YouTubers, hope you guys are with me. And the teams, the engineering group left me already. Mr. S is, I don't see anybody on Teams anymore. But yeah, the engineers left me. Yeah, this is for FVV. I don't blame them. Okay, let's work through. Now S is what we're looking for. What's the distance? What's the distance that this thing moves? It's time killing, but let me do one. I know this one. I'm gonna clean here. I'm gonna do one time and then remaining the other one you finish man. Okay, let's say in the first case, when V final is equals to 28 meter per second, V initial is 4 meter per second. Time, you got the 8 times 60 seconds, and then acceleration 0.505505 meter per second square. You use any other formula that you like. S should be V initial times T plus half AT squared. Let's just use this one and then check where is it gonna go. V initial 8. Okay, you're gonna help me. I'm gonna go onto Excel. Let's see. V initial is 8. No, alive. V initial is 4. Sorry, 4 times initial times T. Time is 8 times 60 plus 0.5 times half A is 0.05 times that one square. The time is 8 times 60 square. I got 7680. What is the answer she says? 7680. You say 7680 exactly. Therefore I get 768 under 80 meter. Completely exactly what the answer requires. This is the answer. What about for the second one? You could use exactly the case. V final is 0, V initial is 28, it's deaccelerating. Let me put it here. S2 is V initial is 28 times t. You know the time it took? Do I know the time? Oh yeah, the time we calculated, which is 50.91 second. 50.9. Okay, I'm gonna do it by Excel. You could see. The second one is I'm going the same formula. 28 times 50.91. I said minus. Remember, I'm using minus now because it's decelerating. 0.55 times half gt square. Remember, times 0.5. This is half. One is g. T square is times what is that? From 50 again 0.91 square. Therefore, the answer I get is 712 and a 73. 71273. That's what I get. S2, the same formula, 712.73 meter. Therefore, what she say? 712.73 meter. Exactly copy. Therefore, I use. This is a very first year equation. V in S is equal V notional times T plus half AT square. Remember, when accelerating is forward, use plus. If it is decelerating, put negative. Therefore, easy wheezy. I could see people are leaving. I know now you are right. This is a very easy question. Question number 3. Do I have any other question though? I'm just gonna zoom in. Yeah, I don't have any. It's only that this is the last question. Let's finish and then get rid of. An unaware football player collides with a padded goal post, so padded goal post, while running at a velocity of 7 meters per second. Okay, V initial is 7.5 meters per second. And the car to stop. Again, you see V final must be equal to 0. After compressing the padding and his body by the distance D must be 0.35. Therefore, what did she ask? What is his acceleration? Rather, it's going to be deceleration instead of acceleration. I believe you guys, you can understand it. Therefore, I will say V final square must be equals to V naught square plus 2AS. A is acceleration, S is the displacement. Then I know the final velocity is 0. V naught square must be equals to negative of that one. Negative by negative will disappear. Remember, I'm taking to the other. Minus will come. Minus 2. Acceleration is deceleration rather. Is going to be deceleration. Forget about it. Or I'm looking for A actually. Yeah. Let me stop there. Let me go take you through. Therefore, 2AS must be V naught minus V naught square. Acceleration A must be equals to minus V naught square over 2 times S. 2 times S. You could see it's a negative by itself. It is deceleration. It's not accelerating. It's slowing down rather. Therefore, V naught is 7.5. I'm going to go back to my Excel, which is equals to 7.5 square divided by 2 times 0.35. 80.35 must be equals to 80.36. I get negative 80.36 meter per second squared. This is the deceleration, it's slowing down. Therefore, what is the answer? She said, exactly 80.36 meter per. Yeah, that's perfect. And then it's asking now, how long does the collision last? Again, I will use the same tactic that I have in my head. Then I say V final must be equal to V naught plus 80. But I know that A is negative. B final is going to be 0. Minus V naught must be equal to minus 80.36 times T. T must be, now you could see both sides it's negative. I will make it. Therefore, V naught is 7.5 divided by 80.36. 80.36. I'm going to go back to my Excel. This one is equals to 7.5 divided by that number. Therefore, 0.0, I got 0.093 second. This is how fast, or no, how long it took, the collision took. And then that's 0.93. Perfect. Correct. This is all what I have for you today. FEVV and the PHYV. For FEVV, if I go back to my, now I'm not going to save this one. Should I save? Maybe. Let me say, okay, I'm going to go back. Do you want to save it? Okay, let me save even. It's good. I'm going to save it. If somebody wants, I could send it. And I'm going back just to summarize what we've done today. Therefore, today, for the PHYV 101 and then FEVV 101, for the PHYV, we were in tutorial 2. We worked through question number 5 to 8. For the FEVV student, we work through the physics workbook B, section B, not A. A was last week. We go from section 6.4 to section 6.5. Actually, I go to 6.5 first and I go back to 6.4. Otherwise, everything is all right. Things are recorded on the YouTube directly. On the Teams is also a section of it only recorded on the Teams. Sorry about the fact that I started recording late in the Teams. You see, I'm tired. Therefore, guys, that's all for today. Thank you for listening. Those of you who will be listening to this video, I was told that most of you have got class during this time, and mostly, I know, you have listened after it is uploaded. Thank you. See you next week. I'm going to stop now. Go back to my system. I'm going to stop streaming. 1, 2, 3.